My project, one in particular, I'm going to give you a bit more background in terms of what we're doing with regard to job creation and sustainable building. To do that, I'm going to give you a bit more background as to what my company is. Useit, we're a Section 21 non-profit organization established in 2009 under a memorandum of agreement with eThekwini municipality. Now, our specific mandates are to create jobs and maximize job creation through waste diversion from landfill, and particularly with a focus on waste beneficiation. Waste beneficiation is a very difficult concept because it's a very small box and a very long value chain. So when one starts looking at beneficiation of waste, one's got to look at everything from sorting and collection right through to remanufacturing and even policy and application. To date, Useit is basically a cost-negative operation. For every rand of funding we received last year from eThekwini municipality, we diverted over 6,000 tons of waste last year, and that saved the city R2.74 for every rand they gave us. Now, the opportunity of that is understanding that 6,000 tons is 1 day's waste in Durban. In doing that, we've facilitated the creation of 2,235 jobs in the last 6 years, and we've leveraged more than 11 times that funding in private sector and additional public sector funding. So this is definitely the way to go. The compressed earth blocks I'm going to focus on, that's one of our main projects, and that specifically is targeting waste soils and builder's rubble. And it's a very simple process of hydraulic compression. Most of us have a pretty conventional view on recycling. We think about paper recycling and plastic recycling and tires and e-waste and organics. And they're a lot more clearer in our minds. One of the things we don't see is this, soil waste. Soil waste is huge. Builder's rubble is huge. Generally, we're talking at landfills across the country, anywhere between 25 and 40% of the waste going into those landfills is this inert soil and builder's rubble waste. And yet we shouldn't be throwing that away. If you look at realities of housing delivery, in eThekwini alone, our backlog is about 408,000 housing units. On top of that, about 34,700 units that have been built already of really dubious quality need to be demolished to rebuild. We're currently delivering at about 6,500 units per year, which is 1.6% of that backlog. Now, if you consider the urbanization rate, we're conservatively looking at about 2.5% per year. Realistically, it's probably closer to 4%. We're sitting on a social time bomb. We believe that the compressed earth blocks is one way of tackling that problem. And if you look at the stats again from our own Human Settlements Minister, who says that the national housing delivery rate has fallen by 25% in the last 5 years. And the backlog now stands at 2.3 million. In 1994, the backlog was 1.5 million. Advantages of compressed earth blocks have been used in many countries around the world. There's certification to the eyeballs, NHBRC, SABS, CIDB, we've got eco standard approval, etc. We're using available soils. We're not looking at a clay soil, we're looking at a clay-bearing soil, so we can use up a huge range of soils. These blocks are fireproof, bulletproof, insect-proof, waterproof, earthquake-proof. They're 3 to 5 times stronger than the minimum compressive requirement for masonry blocks, and up to 10 times more thermally efficient. On top of that, we've proven that they cost 16% less at least to build in comparison to concrete block technology and 45% cheaper than clay bricks. The building process is faster and cheaper. There's no mortar, no firing, and no curing of the blocks. And in terms of carbon footprint, in comparison to a hollow concrete block, we're saving up to 8 tons of carbon dioxide equivalents per 50 square meter build. So there's lots of benefits there. Creation of jobs, skills development, delivery on backlog, energy efficiency, looking at the waste issues, looking at also the creation of affordable, comfortable housing. And it's quite simple. It's a hydraulic compression machine on a trailer. We put the soils, we mix that up with a bit of the rubble or whatever else is available. It's crushed, and we pump this thing out, and each machine can pump out 1 block every 4 seconds. So a set of equipment can produce 7,000 blocks a day, enough to produce 3 houses a day. And it's from there familiar methods to install. So we're not trying to change mindsets. We're looking at very similar methods of building and construction, with the exception that we use a soil slurry instead of a mortar. So again, we're using less energy-intensive materials. It's also a lot easier to build with. We don't need wet-work artisans that take months and possibly years to train. We're taking people off the streets and within 20 minutes teaching them how to build with walls. So it's a no-brainer from that perspective, and that's what the final product looks like. So if you look at the application from an acceptability point of view, we have no problem with the acceptability. From the certification point of view, we have no problem with that. On top of that, we then build in other systems and processes that look at other alternative recycled materials, including, I'll show you in the next slide. But we're building about 2,000 Rand a square meter, which is way below the rate in terms of low-cost housing. We try and include through our projects at Useit a lot of other different project developments, alternative building materials made from other recycled materials, the more conventional stuff that you're used to, the plastic and the paper. Roof tiles, skirtings, cornicing, decking, flooring systems, piping systems, guttering systems, barge boards, fascia boards, purlins, battens, etc., all made from recycled materials, cheaper, stronger, and better than conventional materials. So we moved one of our projects down to the Western Cape, into Stellenbosch, at the beginning of this year. Guys, in KZN, we've got a bit of catching up to do. We've achieved more in Cape Town in 6 months, and it's taken us 4.5 years in KZN. So that's just a little wake-up call. We need to try and get moving a little bit faster here. In Stellenbosch, they had a problem. One pile of soil in one situation, 115,000 cubic meters. It's enough to produce 22 million blocks that equates to 7,300 low-income homes. And we can make 100% recycled blocks. That's the block yard you can see in the bottom left of the corner. Closer to home, in Cornubia, again, one development in one city in part of the province, there's a mountain of soil that's being sent off to spoil. That one little mountain there is 500,000 tons. That can produce 52 million blocks, enough for 15,000 houses. And again, so we can build 100% recycled block, greener, cheaper, stronger, etc. Phase 2 of this program is going to generate 4 million cubic meters of waste soil, enough for another 160,000 houses. So let's put this into perspective here. Something's wrong with the picture. We've got one development in eThekwini, mixed land use, and an estimated 28,000 low-cost houses. From that development, from the cut and fill operations, we're creating enough soil waste from platforming operations to build another 175,000 houses. Remember, this is a 28,000 house development. We're throwing away materials to build 175,000 houses, so we can build 28,000 houses out of cheaper, nastier material we're having to import from miles away. Okay? We can build them cheaper, stronger, greener, and better. The planned destination for those soils currently is landfill. We're now going to cart those things on a 22-kilometer round trip to a landfill site, of which we don't have enough space. So we're now filling up valuable landfill airspace with the waste material that we could build sustainable buildings out of. We estimated that that would cost in the region of about 1.2 billion Rand just to move that soil and put it into a landfill site. We could build everything we need to in eThekwini. So I'm still trying to figure it out. So yes, industrial symbiosis it's a no-brainer, but we need to get the brains behind it to actually make the decisions to make it happen. Compressed earth block homes, it's going to save in terms of transport costs and waste. It's going to save on landfill airspace, 3 to 5 times stronger, at least 20% cheaper, 3 times stronger and more thermally efficient, very low carbon footprint, soundproof, bulletproof, insect-proof, waterproof. We can't get an AK-47 to penetrate my walls. We need a 20 millimeter Browning cannon to put a hole into my walls. So which option would you choose? Simple and proven application of industrial symbiosis and waste management is right here, locally produced, and solves the waste problem. And that's the kind of stuff we're building. So from orphanages and offices and industrial buildings and low-cost homes and standard buildings, research facilities, etc., or we go upmarket. These are 5,000 square foot or 450 square meter homes. These are in Bahia, New Mexico. 6,000 of these built with the waste materials out of that area. And if anybody wants to live in one of those homes, it's a no-brainer. Thank you.